So this is day 19 on Java session actually, and we'll see what is abstract class, what is the syntax of it, what is the use of abstract class with some example. So I am straight away jumping to our project where we were talking about all the Java program, the practice Java itself, or let's create a new package because abstract class and interface is an important concept. So let me make a new package today, abstract demo. And if you want to understand about theoretically what is abstract class, what is the use of it, so there is one good blog or tutorial I found in Java to T Point. There's a website called javatpoint.com. They have declared it in a very good way about what is abstract class and why we use it. That I'll explain. But the things which we should understand about abstract classes, these 5 points. An abstract class must be declared with an abstract keyword. First of all, it's related to class concept. Okay, it's related. It's a special kind of class. It's a special kind of class. If somebody asks you, okay, what is abstract class? So the first sentence should be, it's a kind of class, or it's a special kind of class where you can have abstract and non-abstract both kind of method. So your question must be like, what is abstract method, what is non-abstract method? We will see it with the example. Third point is it cannot be instantiated. Instantiated means, can we make object of an abstract class? We will see this point. It can have constructor and static method also. Okay. It can have final methods which will force the subclass not to change the body of the method. Perfect. So these are the basic points about an abstract class, and you will shortly get to know why abstract class is a good thing. Okay. So let me, I have one example. So I'm creating a class here and I'm giving the name as robot. Okay, robot. Okay, and we will make this class as abstract class. So abstract is a keyword here. Okay, fine. What is the use of it? So let me declare something which is same as any other class. Can I write integer x? Is there any problem? No. So abstract class is same as any other class where you can declare a variable. Perfectly fine. Can I create a function like public void? What robot can do? Let's say robot can walk. Okay. And can I write something here? System.out.println, and I will write here, I am a basic robot which can walk, something like this. That's perfectly fine. Can I make a main function here? Public static void main and string args, and here Can I make an object of robot class? Let's see whether it is possible. So I'm writing robot R is equals to new uh, robot. Okay. Now it is showing me one error. It is saying me cannot instantiate the type robot. That means first logic about abstract class is, sorry, just a minute. So first thing about robot class is, sorry, abstract class is, you cannot instantiate it. Okay, so I am commenting it out. Then why it is required? Why we need abstract class when we cannot create an object of it? So the basic thing about abstract class is creating a structure so that all the subclass, all the child class will implement all the required thing about an robot. So here, let's say I'll write public void talk. Okay, public void talk. Can I write it like this? This method requires a body instead of a semicolon. Okay, why it is saying this? Because you cannot write, this is called concrete method. So what we say at the seventh line, if you see, we call it concrete method or non-abstract method, right? If you want to just declare it like this, it's not possible. It looks like a function call and then you are making it public void, right? It's not good. So you should make it abstract. Okay, then the error is gone. Let me write something and then I'll explain what we are doing here. Abstract, uh, what a robot can do, let's say serve. What is the meaning of this? We are creating abstract method now, but this is just declaration. We are not defining it. We have not written the implementation part of it. Then who will implement it? So all the subclasses which will extend the robot class, they have to mandatorily implement these functions, right? So let's say this is a basic robot and this robot has its own function walk. That's perfectly fine. A basic robot can walk. But talk and serve, we will implement in a newer version of robot. Talk and serve, we will implement in other version of the robot. So there are different kind of robots in the market, right? A basic robot which can walk. But what we are doing here is declaring the abstract method so that whoever will implement, sorry, whoever will extend the robot class, they have to mandatorily, you know, implement these functions, right? So let's make another class, new class. Let's give name as, let's say, Chitti. And this class Chitti, let's say, extends robot. Let me write it, robot. Now let's understand, the moment I write a particular class implements robot abstract class, it is showing me some message. It is saying The type chitti must implement the inherited abstract method robot.serve. It will show for other function also. As of now, it's just showing for the serve. So what it is saying that if you want to extend the robot, you have to implement talk and serve both. Okay, so let's write it. And this error will, as of now, it's showing me error that you have to implement serve and what other function is there? Talk. So let's put it. So I'm writing it like this: public void serve. Okay, and I'm writing here, just a minute. I'm writing here Chitti type of robot can serve. Just a message. But still there is an error. It's saying talk also you have to implement. So I can implement public void talk, and here we will say Chitti robot talk, something like this. Okay, so now we have to understand that I'm going back to the abstract class robot. We have made one abstract class where we can have the concrete method as well as abstract method. Now the question is, what is abstract method? Abstract method is not having its own implementation where it is declared. You have to implement or define this function in its subclass, right? And why I'm saying this, you will get to know why this is a good kind of implementation. Let's create another robot, another type of robot. So we'll make it, let's say, transformer. Pardon me for any spelling mistake if it is there. So transformer is also, let's say, extends robot. The same kind of error we will get, that you should have implementation for serve and talk. So let me copy this, and we'll have this, and here we will say farmer. Okay, so let's understand that this structure is like this, where robot is a parent class, and there are two kind of robot. One is chitti we made, correct, and another one is transformer. Both of this class extends robot. This basic robot can only walk, okay, but this chitti, which is extending the robot class, can talk and serve. Transformer can also have its own implementation of talk and serve. So transformer may have its own implementation how it want to talk. In the same way, serve. Chitti may have its own way of serving and its own way of talking. So this is giving you a freedom to make your own way of implementation, okay, as well as it is making a foundation for all the new kind of robot which is extending the basic robot pattern and making their own way of doing it. Let's understand in another way. Most of the cars, they have a platform, a same platform, and over that the company makes changes related to acceleration, related to brake pattern, related to clutch or whatever. So for example, let's say if you heard about Tata company, they make one platform which is like Tiago is made on a particular platform, and the same platform is used by uh, Nexon, I think, right? So it's like this, or you can understand in other way. Most of the what you see in your phone, Android phone or laptop, there is a motherboard. Do you think every company is making their own motherboard? It's not like that. Probably like Huawei or Asus, right? Those companies are making motherboard. So it's a platform. Over that, you can make, you can put your own way of other thing, like how you want to put the audio pattern, how you want to put in your Android phone, like what other functionalities you may have, setting functionality and everything. In the same way, here is a robot class, abstract class, which will give you a pattern, that basic thing we have, and there may be multiple basic functions that we will say non-abstract function or concrete function, as well as it will have the abstract method, which is saying that these two functions, whoever will extend the robot class has to implement. Okay, now the question is how we will call these functions. So let's try this thing. So Chitti, which is one class, let's make main function here, public static void main, and string argument. And here, can I write Chitti C1 is equals to new? It's possible. Now the question is, when I write C1 dot serve, right, what will be called? Obviously, this function will be called, right? But when I write C1 dot walk, so what will be? Because walk is not a part of this class. Walk is there in the parent class, so you can call it by. So let's see how, when we run it, what will happen. So if you see here, it's printing me that Chitti is a type of robot, can serve. That's fine. We have written in the serve. As well as when I called walk, this, let me show it in a proper way. Like I'll put it like this. Just a minute. So if you see here, these two classes, the robot class at the right hand side, let me delete this. This is not required. The robot class is an abstract class which has walk function, and this particular Chitti class has serve and talk implemented. And when I'm calling c1.walk, if the function is not present in the child class, it will go to the parent class and it will have, okay. Because let's understand, when you make a platform, you will provide some basic things, and all the specialized thing, customized thing you can put then. It's like this. So for example, Android is a platform, operating system. Different companies like MI, they make their own MI UI pattern, or Motorola will make its own OS over Android, right? Samsung will make its own and will give some kind of other name, right? It happens like this. So in the same way, when you have the abstract class, it is providing you a basic platform. You may have the basic implementation also, okay? And it will have some abstract class which will bind other robots, that you have to implement your own talking pattern and serve pattern. I'm giving a real life example, actually, like real, how maybe robots are implemented, right? But you can think of other example also. So, okay, I'll explain everything. Let me come back here. So now let's make another class. So there is another concept that one abstract class can extend another abstract class. That's possible. So let's do that. So we will make one class which will be named, let's say, new robot. So I'm giving a name, new robot. New robot. Okay, fine, finish. And let's make this new robot as also abstract. And can I extend the old robot? Let's see. Extends robot. Yeah, it's possible. This time, it is not binding me to implement the functions which are abstractly declared in the robot. So that's the difference. When I try to extend the robot class through a normal class, which is not an abstract, Chitti is not an abstract class. So there was a binding that I had to implement all this thing. But when I am, this new robot is also an abstract class, and I want to extend another abstract class, then it is not showing me an error that you have to do something. Okay. Why? The reason is all the abstract function of robot will come to the new robot, and it will still be abstract. So I'll show you what I'm saying. So let's create a function here for the new robot. So we'll make, let's say, public void, let's say, new robot can fight. Okay, new robot can fight. And let me write it here. I am new robot. I can fight. Great. And can I make abstract functions also? Yes, because it's an abstract class. So I'm making public void sleep. Okay, so we want that the robot should sleep also now. The new kind of robot should sleep also, right? Now the question is, any new class. So I'm making a new class. So we will give it a name as, let's say, I'm not able to find. So let's say Ra1, something like this. Okay. And finish. Let's say this Ra1 kind of robot extends new robot. It extends new robot. So what is the error I'm getting? It's saying that the type Ra1 must implement the inherited abstract method new robot.sleep. Okay, let's do that. So I'll implement public void sleep, and we will say that Ra1, a new kind of robot can sleep. Fine. Still I have error. It's saying that you have to do serve and talk also. So why it is saying, let's understand that. So this was the first diagram. Another diagram is robot, the basic robot, and then new robot. Both are abstract. This is also abstract, and the new robot is extending another abstract class. So whatever class, there is a new class called Ra1, which wants to extend new robot, has to implement all the abstract functions present at the new robot, as well as all the abstract function which you have in robot, the basic robot. It's like this. Okay, so that's why I have to make this walk and sorry, um, the serve and talk in Ra1 also. Let me. So Ra1 is a new robot. Ra1 new robot can talk. Done. Now, oh yeah, we did it right. Now let's. What is abstraction then? How we are implementing the abstraction? Now you will see what is actually what we say abstraction. Now I am making public static void main we want to, because call some of the functions and we'll see what will happen. So here I'm writing that Ra1 R is equals to new Ra1. Okay, and if I call R dot serve, so what will happen? Obviously, it will call the function which is present in the R1 itself. Obviously, it will call the function which is there in the here, like in the 10th line. Well, let's assume that this serve, okay, serve is fine. Let's delete this talk. I'm doing a control X, and I'll put it into the new robot only. So, okay, talk we are implementing. So new robot is a extension of robot. Okay, and we implemented the talk here. Now, if I will call r dot talk, so what will happen that it will call the function of its parent class, right? Because the talk is not present here. So obviously it will call. So let's understand Ra1 is a new kind of robot which can serve and sleep on its own way. But for the talking pattern, it will use its parents function. It's like this. Okay, but that is not abstraction implemented yet. This is a simple what we say, it's a simple parent-child relationship here. So if you see here, Ravan new robot can talk. Ravan is sorry, it should be not Ravan here. It's just new robot can talk. Okay, let me run it. So new robot can talk. Ravan is a type of new robot can. So now can I write like this? That robot um, R2D2 is equals to new Ravan. You will feel like what we are doing here. Can I write like this? Yeah, it's saying that you can do that. And can I call the this R2D2 is not looking good. Let me make some other name here. Is just uh, T, something like this, robot T, and I'm calling T dot. So let's understand what we are doing here. It's like creating an object of Ra1, okay, but putting that object reference to T. And when I call T dot talk, right, it's not showing me any error. So actually whatever we have seen till now is when we create robot T, and if I call T dot something, so it should call the function of the robot class, right? So robot has talk, but there is nothing there. What it will do then? So this is the way we implement the abstraction. And let's understand in another way is there are multiple players, right? There are multiple players. So let's say there is a what we say video game, and how you do it, you select the players, right? Or in like Need for Speed, or if you know 9 Asphalt, there are a lot of video games, car racing. You select the car, right? Or in some other video game, you select the player for the fight. So you select a kind of robot. So for us, actually what happened when you select a particular kind of car or the robot, it creates the object of that new kind of robot. But the the functions are same. So for example, there are two kind of fighter in a video game. The both can, fight in a particular way, both can walk, both can jump. So for you it's a robot only. For sorry, for you are thinking that you are a new kind of robot, right? But for the interface where you're using your keyboard or joystick or anything, right, you are a robot. You are a robot only. So this is the real implementation of abstraction, where you selected a kind of robot from your screen, but actually the functions will be called through the robot object only. It's like this, robot reference only, right? So what will happen in this way? When I say robot T is equals to new R Ra1, which is like Ra1 is, if you see this particular pattern, this is actually grandchild of robot only. And we are creating reference of this, right, basic abstract class I'll not write basic, it's a base abstract class, and you're calling the function of your grandchild's function through, you know, reference. So this is the T, and you are making like this. So I'm writing again here. So we wrote, let me copy this. Robot T is equals to new one. And then we are calling functions. So T dot, right? So basically all these things are robot only, right? It's base pattern only. And we'll call the function from there only. Right? It's like this. So if we run this, and so it's, see what it is printing. Okay, let me comment out this. Okay, now we will run it. So it's saying new robot can talk. Why it is saying new robot can talk? Because this talk function is defined in the new robot only, right? So raw1 is following new robot's talk pattern. It's like this, okay? Because it doesn't have its own talk function implemented. That's why it is having, now can we call serve. So serve, which is not defined here, or can I call fight first? So if I say t dot, oh, it's, I'm not able to do that. So when we wrote robot t is equals to new one, and I'm saying t dot fight, it's not coming. Why? Why it's not coming? Because fight function is not defined for Ravan, and the basic robot, right, have only walk, talk, and serve, right? Ravan, which is extending the new robot, right, and new robot has that walk, fight function, right? But we are not able to call it in this way. Why? Because robot doesn't know, how many childs it has. It's like this. So you can call all the functions which is there for the basic robot, as well as all the functions which you have for your new Ravan robot. It's like this. So one abstract class can extend another abstract class and can define it. So sleep is still not defined. So this raw one can, okay, sleep we have made. So you can call sleep. Sleep is fine. You can anytime have t dot, just a minute. You cannot call the sleep. So if you want to call the sleep pattern, you have to make its own object. You have to make raw one's object only if you want to do it. So for example, this one where you make your own object here, then you can call, but you cannot call the functions of your own class here. Okay. It may look weird to you. So when we call serve, let's see what is happening. When we call serve, so it's saying Ravan, a type of new robot, can serve, right? Serve is fine. It's working fine. But then why not this sleep is working? T dot sleep, which was defined here as an abstract, right? We have implemented here. Let me see if there is any spelling mistake. No, there is nothing. And sleep, we did not define on the base class. And serve, which is a part of abstraction here, we are able to call. Okay. So the thing is, so we actually a kind of um, broke the rule. What we should do actually is, when you have a robot class or any abstract class, all these functions should be defined in its child class. Okay. So actually we broke the rule that we did not uh, define the serve here, right? And generally there is no, um, the way we have written here, like one abstract class is doing extending another abstract class, this generally doesn't happen. It works like this, or how we have written here, right? So if you want to call the sleep or anything here, right, you should make then its own object. So ra1 is r is equals to new ra1, and then you call whatever serve or that thing you want to call. But the purpose of abstraction here is, you can call all the functions which is a part of mandatory functions, which is all abstract and non-abstract functions on your hierarchy. It's like this. Okay. So this is how abstraction works. I'll share this example with you. You should try changing something, make your own classes then to understand this. And another part is, we can make, let me go to robot, and we can make static variables. So when you have static variable, let's say 10, 10, okay. And in the new robot, let's say anywhere, can I write x plus plus? Will it show me error? No, it's not showing me any error. So can I print the value of x? Let's see what will happen. So if I write system.out.println, uh, sorry, t dot x. Okay, let's run this. It is printing me 10. Okay, why? Because it is not changed. We changed it in a fight function. We changed it in a fight function, but we did not call it, so there is no issue, right? So talk we call, right? So let's make x plus plus here, x plus plus, and if I run this, it is printing me 11. Why? Because we called this talk function, right? And that is calling this particular function, which is changing the value of x, which was a static variable in the parent class, which was 10. So when you say t dot talk, that function is called, x plus plus happened, and now the current value of x is 10. You may be thinking that it's a part of the robot, right? It's a part of the robot class. How we are able to have it in this variable? So it's possible. Okay, it's a static variable, and we made a reference of t robot only, so that's fine. We have the access of x, but meanwhile we changed it. Meanwhile we changed it in the parent class, so it's fine. Another thing I have shown you as it can have final method. So what is the final method? Can I write here a particular method called public void final, and I'll say sing. Okay, and can I put the implementation public final sing, and I will say system.out.println basic robot and sing. Let's say something like this. What will happen after this? If I make any function as a final, okay, let's say chitti, which is extending the robot, can I override it? So what I'm saying is, can I write public void sing something here? So it is showing me an error. It's saying me cannot override the final method from robot. So what is final method? Final method is a kind of function which is finally defined. You cannot override it. You cannot redefine it. Okay, so that's why we are getting this error. What is the use of it then when we cannot override? So it's like putting a binding that if you want to call, if you want to call the sing function, it will work as the basic robot only. You cannot make your own, sing function. It's like this. All the robot, all kind of robot who will extend the basic robot cannot implement their own sing functionality. It's like this. Okay, they have to call the basic robots sing functionality only. So this is all about abstraction, and you must understand now what is the use of it. I'll share this with you guys, this particular chapter. There is another example here. It's like related to bike and other things like shape, draw. you should also try this example also. You will get to know like why abstract class we are using and what is the use of it. They have given good example here, so I'll share that part with you. Let me put it into the chat window, and as well as I'll give it on the notepad also, don't worry. So this is all about abstract classes.